Hey everyone, welcome to Inside Out BIM. Today we're going to talk about the creation of the Bat Cafe facade using Dynamo and Grasshopper. Actually, I'm going to focus on Dynamo and Revit workflow, and not only I'm going to show you how to create this facade, but also how to extract all of the information that you need. Here I've just kind of I just wanted to demonstrate how you can get the length of the pipe in the schedules. For example, I have one pipe and the count of the we have 5 pipes of this length, right? So yeah, I'm going to show you how to extract the information out of this. And I think there's only one challenge. So is to how create an algorithm for the shape. Because if I go to Revit, oops, it's Dynamo. So if I go to Revit, here we have Revit families. So just pipes, right? And their length varies, right? So we have different lengths that form this type of shape, right? So as you can see, it just have a starting point that goes from here, and that has just different lengths. So that is the whole idea behind that workflow. So if I go back to the presentation, so you need to create a Revit family. Then you need to make sure to make the parameters that you want to schedule shared. So here I just wanted to get the length in my schedule, so I created this one as a shared parameter. And just the logic for the script is to generate a grid of points, right? And we need to change their y-axis that way, so that would form this shape. And then we just need to you can use a lot of methods. Actually, I just used I just moved all of these points away from these grid of points. As you can see, right, I just moved this on some distance, and I just connect them using lines. So that is the whole idea, to create lines between these points, get their length, and by using set parameter by name, we can actually set some values to the length of the pipe. So as you can see, I'm going to show you just a quick demonstration. So we have element set parameter by name, and we have the pipe length parameter, and I'm just getting these parameters out of curve lengths. So yeah, let's create this from scratch, right? So let's close Dynamo script. Okay, let's go back to, and also yeah, I'm going to show you that in Rhino I've got the same thing using Grasshopper. I'm just going to show you the workflow also, but I'm going to focus on Revit one. So yeah, let's create a new project. Create new. Let's go create new project. Let's go with the default architectural template. And we need to start with the creation of a family. So I'm going to go to File, New, Family, and let's go with just some simple generic model. So what I want to have is that I've built one already. Maybe I'm just going to show you how I did this. So here I've just created by extrusion. So I went to create extrusion, right? And I've just created an extrusion, right? As you can see, I have 2 circles. Make sure that when you create a circle, make sure to turn this center mark visible on and just align this. It's really important. So I'm just going to show you on this family, just with simple model lines even. I'm not going to build the family from scratch, just to show you how we can do this. So when you create a circle, you can make the center mark visible, and you have this cross at the center, and then you can use align tool. You can find it here, or you can use a shortcut AL, and you can align this, so that make sure that the center of that circle stays always here. And here I've just built it. Oops, I just need to go to that pipe family. So I've just built it 2 circles and created the parameters for them. So the radius for this one and the radius for this one. And but here I just wanted to, and first of all, the second radius, right? So I have one radius and the second radius. If I go to the dimension, and let's kind of place it here so it's easier for you to understand. So I don't want the user to go into parameters and change the radiuses for all of these. I think here what parameters are really important is the first radius, right? Is the radius of that circle and the thickness. So basically I want my user to set the radius, this 120, and this thickness 20. So how we can achieve this? So I have the pipe radius parameter that is 120, and I just created the pipe thickness, and my pipe thickness, for example, equal to 20. So and based on this parameter we calculate this radius. So we calculate this radius. As you can see, that one, if I go to added extrusion and if I select this parameter, I can see that this parameter is controlled by the formula pipe radius minus pipe thickness. So right, so if you think about this, that is the, so that one is the radius 120 minus this thickness, and I'm getting the radius for this one. So it's just simply to do, it's so simple to create this family, and then I just create a parameter like pipe length, and I constrain this on both sides, and that's it. So to not waste time and just recreate this family, I just showed you how you can do this. So let's load this into our project, right? Into our project 3. And now let's go to Dynamo to start building that script, right? So let's go to manage and let's open up Dynamo. Let's wait for a minute to fire Dynamo up. So yeah, there we go. Let's go to new. So first of all, I'm gonna go back and forth so you can understand what I'm doing. So first of all, we need to create a grid of points. So to create a grid of points, we're gonna be using a node that is called point by coordinate system, right? Oops, point by coordinates, right? X, Y, and Z. And here I would like to have what I would like to have actually as parameters to define. So for example, I would like to go from 0, and I would like to specify the quantity of them and the step of the panel. So for example, I would like to say, you know, I have 10 points and I have this step, right? You can, just to show you how that works, if you just type some real numbers, right? Because here I'm introducing variables. I'm just going to show you. But if you type something like, I'm going to go to 10 with a step of 2, right? So it will create a sequence. So you will end up with 10 items, right? As you can see, 10. Here in programming, we start from 0. So actually we have like 9, but you have 10 in total. And here you have a step of 2. You can have like 3, and it'll just generate like 10 numbers with this step. So this is exactly that I want to have. You can copy this by going Control-C or just Control and drag, right? So you can do something like this. Let's use slider. So slider to control these parameters. So we can control the quantity, right? So for example, how many? Let's make them the same, right? You can make them be kind of different, but let's make them the same, right? And slider for the for this step, right? So for example, you can hold on Control key. As you can see, when I hold Control key, I can actually do this like that, so simultaneously. So now we have a set amount of numbers, right? And we can connect this to the X and Z coordinates, right? X and Z. And as you can see, what happens right now, that you have something like this, because it takes this point, goes to 0, it takes this point 8 that goes to the X coordinate and connects this to the 8, so that moves that up. So we need to change the lacing to cross product. So when you change the lacing to cross product, each number, so that 0 will go through all of the numbers, right? So that is, so each number will go through all of these numbers. That is the logic. If you have this sort of a warning, that is not a big one, because it's just about the scaling. So if you have this type of warning, you need to go to settings, geometry scaling, and make this large and apply changes. and now it will disappear. So when we have something like this, actually I was comparing two workflows that I was doing, and the one I've done that was using Grasshopper, right? So here we use something that is called an array of points, right? So if we compare two workflows, so here we can use jump. So if I go to actually to transform, I think, yeah, to transform, here we have a rectangular array, right? So this is the node, rectangular array. And if you create a rectangular array, it's actually the way how we use cross product in Dynamo, right? So that is the whole idea. But we need to, as you can see, what I have over here is that I have a set of points, and each list represents this set of points, right? So as you can see, that it goes like this. So each list, but we need to have them differently. We need to have this one as the first one. So I can use list.transpose, and that list transpose, what it does actually, it creates that in a different order, right? It just takes each item. So for example, as you can see, we have a list, right? And a list of these points that goes vertical. And that list contains, as you can see, this amount of points, 13, right? 1, 2, 3, right? As you can see, it goes up. But what transpose does, it takes each first item of each list, right? As you can see, not first item, but that just goes like this. That reorders the list. So if I look at transpose, now my first list will go in this direction. So just changing the direction, right? So now we can turn off the preview of this so we don't see this one. And now I would like to flatten this. So we can flatten this. And the whole idea why we did it is to get x and y, x and z coordinates, right? So we can actually, there is a cool method to do this. So sometimes you need to just get some coordinates, like in our scenario, it's x and y coordinates, and x and z coordinates, and we need to change y to create this sinus shape, right? So what we can do is that we can get x, a, y, and a, z. That is another way of getting, like, because you can type here point z and or x, and out of points you can get the coordinates, right? So that is another way of doing that. So now we can get x, y, and z. And to make this shape, that is the algorithm that I found by a little bit of trial and error, and by seeing that how that can be done in Grasshopper. So basically, to make this shape, first of all, you need to have points that go in this order, right? From left to right, from left to right. And then you need to get the sinus of the, so basically we need to create point by coordinates, right? And x and z are still the same, but y will be different. Y will equal to the sinus of x. Then we can copy this one. You can go Control-C, Control-V. So the sinus of x and the sinus of z, right? Two of those sinus. We need to multiply them, right? And multiply them by some factor so they can get bigger, right? Because if now I connect this, nothing changes. But if you go with the and multiply this by c, for example, add one more variable and add one like slider. Now if you change this, as you can see, because, and actually to make it be more visible, you need to just increase the number and the just the step maybe, right? I just need to hide, let's turn off the preview of these points, right? Of these ones, and there you go, what you have. So basically what we did is that we used x and y coordinates, x and z coordinates, and we changed their y, right? So now if I change the step, right, and that gets bigger, it just kind of like makes it bigger. But if you change the quantity of these ones, it will add more of a curvatures, right? That is exactly what we have, this type of curvature, this type of like shape. So now it's pretty easy, right? So you get the points, you have these points that are just flattened. If I turn on the preview, right, you have these points that are flat, that without curvature, and that is exactly what we need. If I go back to the presentation, that is exactly what we want to end up with, right? One side is just flat and the second one is with this curvature. So what I can do is that I can go to Dynamo, and out of this list flatten, right, we can go geometry.translate, and now we can go with the geometry, direction, and distance. So what that node does, it waits for the geometry, it waits for the direction, and the direction should be y. So y-axis, and the distance, let's create a slider, integer slider. Let's make this small, like 8, doesn't matter. You can make this bigger, right? And let's hide this, the preview. So now this is exactly what you have, right? So as you can see, you have points and points, right? So basically now you can create a line between two of these points. So line by start and end, by start point and end point. So that will be my start point, that will be my end point. And this is what we end up with, right? Let's gonna make this bigger so you can see easier. So yeah, we generated points, we transpose this, and if you really think about how that works, how these points make this curvature, it's pretty easy, right? So you can click Control I on your keyboard, right? And that will isolate elements, right? Control I. And now when you select some particular points, you will see how that works. So for example, here, my first row goes from 0 to how many we have. So go to quantities, right? I think that is the quantity 32, right? So 32 points. So as you can see, first 32 points equals to 0. And actually, why? Because we have here we have the z coordinate of 0. Because if you're thinking about that z coordinate, here it's 0. So multiplying by 0 will give us 0, right? And then we have some numbers. So for example, 33rd point, right? I need to go to 33rd. As you can see, from the second row, it starts to kind of blend, to create these waves, right? So as you can see, it goes 5, 10, 12, 12, right? So it goes like this. So kind of makes this bigger, and then it goes in different directions. So that is sinus, right? It's just a little bit of a playing around with this. You can actually match the indexes and see how points are changing, right? So now we get these lines. So from this one, it's pretty easy to create everything, right? So we need to get the length of this line, right? Curve.length. So we can get the length of each line. And now we need to go with the family instance, family instance. Let's go by point. So we need to have family type. So let's type family type. Family types. I'm gonna go and find my pipe, right? Let's make this as a manual one, and it's all up to you what you want to change. Why I did this as a manual? Because I want to create my family type. I want to make my starting point as, let's go with this curvature ones, right? So that is going to be my starter point, and now I need to specify the length, right? So I can go set parameter by name, that'll be my element, that will be my parameter name, will be my actually ms dim pipe length. I think that is the correct name. You can go and just place this family somewhere over here and just check it out. So dim pipe length. You can also control the thickness of this one. Let's do this, right? So you can go and create pipe length, parameter name, and this will be my parameter values, right? So now what we're doing, we're placing this family and we're setting the parameter values. I think now the radiuses will be really huge. So we can go and copy this parameter by holding Control key, connect element, and now copy this one, and that'll be pipe radius, right? Pipe radius, parameter name, and let's make the value really small. It's gonna be even like number slider, and let's make this like maybe like 5 even. So it's just gonna be a small number, 5. It's gonna be the radius. Oops, parameter name, parameter value. And the same we can do for like the same element. Here I want to have, pipe thickness, right? Pipe thickness. You can connect to the parameter name, and this will be the value. Let's make this two really small ones, so it's not lagging, right? I hope that won't crash. Let's maybe make it really small, but it's small, it's not that big, I think, right? Let's run it. So yeah, I hope that won't crash, but that shouldn't actually. So let's wait for a minute before it runs. Yeah, I hope that works. Yeah, it's really small, but what's the point, right? You can delete this pipe, right? But now what you get is the same thing, right? So now you have, and that is totally flexible. You can play around with angles. Oh, not with angles. You can play around with the like pretty much with everything that we set out. For example, the length, the curvature. So if I go back to Dynamo script, right, we can make this bigger. For example, I'm just gonna change like to smaller values, but 30, right? And let's see what happens. Okay, I did this to manual, right? So it takes a lot of time, but actually you can play around. Everything works. You can change the pipe thickness, you can change the pipe radius, you can change the curvature of this one, especially when we multiply numbers, right? So it's pretty much flexible. Now what is really important is how to schedule this. So what I did, I've told you just in the family, right? So if I go to family and types, here I have calculated pipe, dimension length, which is a shared parameter. If I go to edit, as you can see, it's a shared parameter. How to create a shared parameter is pretty simple. You go inside of family parameter, you click on shared parameter, you go to select, and here you go to usually to edit, and here's where you browse that file. If you don't have one, you just create. So you just go to create and just save this somewhere, right? So you can save it. And now you can go and create some groups. So for example, here I have some groups, so you can create a group like name, I don't know, and you will have a name of a group, and here you can have like parameter like length, for example. I'm just gonna show you like MSL, for example, right? And we can create this parameter. So now I can add this. I can go to name and just add this parameter as an instance, and I can say, let's make this equal to the length, right? Or pipe length, the same one, right? So there we go, MSL. So now when I load this back to the project and I override this, and now when I go to schedule and quantities, so when I go to create a new schedule of quantities, go to generic models, and now I can go with the family and type, doesn't matter, or just type. You can see we have this parameter in the schedule available, MSL, right? And let's include something like count, maybe, whatever you want, right? So now you have pipe, each pipe, you have the length of that pipe, and you have how many of them. You can actually sort this by the length, right? And uncheck itemized every instance. What that will do is that it will give you the numbers of pipes that have the same length. So for example, this type of pipe, the amount of them is equals to 13, and the length of them is 25. So if I go highlight in model, so all of these pipes have the same length, and yeah. So basically, yeah, that is exactly how that works. So yeah, that's it for this lesson. I hope that was a useful tutorial in learning a little bit more about creation of facades using Dynamo and a little bit of a Grasshopper. I don't think that I've covered actually Grasshopper, but if you go through that like in a quick manner, right? So we're just creating, here we're using an array. So here we can use an array for this one. So the differences are that instead of just a set amount of points, a grid of points, we create an array that has like, in Grasshopper that is a little bit different, right? So here we're just using an array. Maybe I'll show you in another video like the Grasshopper method, but the differences are that instead of just creating using cross product, like points using cross product, we can create a rectangular array. And actually, yeah, we also get the x and y coordinates. We get the sinus. We create a sinus for this one, and we're just gonna creating the same thing actually. As you can see here, we've generated points. Then we create new points. We use x and z, and y is actually the same sinus. And then we just create lines. So this one is creating lines. Here is the difference that we create like really pipes. So we have pipes. So they're just some pipes, right? So that's it. That is like the total workflow. So yeah, I think that's it for this lesson. Again, thank you for watching this video up to the very end. If you're not yet subscribed to this channel, hit the red button down below, and I'll see you very soon in my next video.